Okay, so we're talking about solving compound inequality with or. That's the last thing we did. We were talking about when you have two inequalities with the word or between them. That means that the solution set is going to be any x value that would work in either one of those equations. So we did on this one, we found out that x could be less than or equal to 7, or x could be greater than 12. So any of those values solves this compound inequality. So you're just including all the possible x's that work in either one. So now we're going to talk about if you have the word and between two inequalities. When you have and, that's restrictive. That means only tell me the values of x that are going to work in both of them at the same time. So here you've got negative 1/4 t is less than 2. And if you multiply that by 4, you're going to get that negative t is less than 8, which means that positive t is greater than negative 8. If you multiply by negative 1, you've got to flip that sign. So t greater than negative 8. If you were going to graph that on the number line, you would just graph negative 8 and greater, and you'd use that parenthesis on the end because you're not including negative 8. But that's not the answer. That's just that one inequality right there. The other inequality, 0.52t is greater than or equal to 1.3. If you divide by 0.52, you're going to get that t is greater than or equal to 2.5. And that is going to look like this. It's going to be 2.5 and everything above. So you're using the bracket now to say you're including 2.5. So this time we don't want both arrows. We just want to pick the one that has values that would work in both equations at the same time. So if you look at this, you've got all this area over here that doesn't work in both equations. The numbers over here, like -5, -3, they do work in the t greater than -8 inequality, but they don't work in the t greater than or equal to 2.5. You're looking for the values of x that work in both equations, and those are going to be these values. The values that go with the blue arrow, all of those actually work in both inequalities, because if something is 2.5 or greater, it also is greater than -8. So that's the arrow that is going to tell the story. That's the arrow that is actually the solution set to this compound inequality with the word and in between. So if you're going to write this in set builder notation, you would say x such that x is greater than or equal to 2.5. And if you're going to write it as an interval, you would say from 2.5 to infinity, and you would put a bracket on the 2.5 because you are including 2.5. Okay, so sometimes a compound inequality joined by the word and is written as a three-part inequality. So you've seen this before. If you have 5 is less than -2x plus 7 and -2x plus 7 is less than or equal to 11, you can also just write that as one three-part inequality. You can write it as 5 is less than -2x plus 7, which is less than or equal to 11. So when you solve one of these three-part inequalities, you can just, if you add something to one side, there's three sides. If you add something to one side or subtract something from one side, you would do it to all three. So here you would want to subtract 7 from everything. So you're going to subtract it from the 5, and then from the -2x plus 7, and from the 11. So you'd have -2 is less than -2x is less than or equal to 4. And then you divide by -2, divide everything by -2. And when you do that, you got to flip all those signs. Everything's pointing the other way. And you have 1 is greater than x is greater than or equal to -2. And that is all the values of x that are between 1 and -2, including -2, but not including 1. So you'd write the set builder notation, all x, such that 1 is greater than x is greater than or equal to -2. And if you wanted to write the interval notation, you would put a bracket on -2, and you would just say -2, the interval, -2 to 1, including -2. And then to graph it, you would just put a bracket on -2 and go up to 1 and put a parenthesis on 1 to show that you're not including 1 in the solution set. Okay, absolute value. Now we're going to go back and talk about absolute value again. The absolute value of a number, as we said, is simply its distance from 0, and numbers that are close to 0, therefore, have a small absolute value, and numbers that are far away from 0 are going to have a bigger absolute value. Makes sense. Distance, if you're close, you got a small distance. If you're far, you got a big distance. So if the absolute value of a number is less than 3, this means that the number is closer to 0 than 3 spaces away. So it's going to fall somewhere between -3 and 3. If I say the absolute value of x is less than 3, I mean you can't get any further away from 0 than 3 away. So you can go as far as 3 or as far as -3. That's it. So the solution set for the absolute value of x is less than 3 is this set notation x, all x, such that x is between -3 and 3. -3 is less than x, which is less than 3. So that's the kind of situation you get when you have an absolute value that is less than something. That gives you a little group around 0 because you're kind of walling x in. You're keeping it from getting too far away. So it's a little group of values huddled around 0. If you have greater than, when you're talking about an absolute value inequality, if the absolute value of a number is greater than 3, this means that it's further away from 0 than 3. So it will be in one of these two disjoint sets. Either x is greater than 3, so further away than 3 over here on the right, or less than -3, because it's further away from 0 than 3. So the solution set for absolute value of x is greater than 3 is going to be all x such that x is less than -3 or x is greater than 3. So less than, one group of little values all huddled around 0. Greater than absolute value, you're going to have two sets shooting off in opposite directions. So I have this absolute value problem, and what I'm going to do is go ahead and isolate that absolute value just like I did with the equations involving absolute value. So I'm going to have to add 3 to both sides here. So I'm going to have 2 times the absolute value of 6 minus m is less than 10. Now I've got to divide both sides by 2, get that absolute value completely by itself. So we're saying that 6 minus m has an absolute value that is less than 5. That means it never gets any further away from 0 than just 5 steps away, which means that it is less than 5, but also greater than -5. So that's what we have to say about 6 minus m. It's less than 5, and it's got to be greater than -5. You can't get too far away, so you've got to wall it in. All right, and then you just solve for m. So you'd have -m is less than -1, which means m is greater than +1, and -m is greater than -11, which means that +m is less than +11. So we have m being between 1 and 11. It's greater than 1, but less than 11. So that is an and. It's got to be both. So those are the values. If you write it in interval notation, you're going to say from 1 to 11, not including 1 or 11. If you write it in set notation, you're going to say all x, which really I should have said m, all m such that x is between 1 and 11. So 1 less than m, less than 11. And then if you were going to graph it, you would put it on the number line with 1. You're writing all the values between 1 and 11, but you're not including 1 and 11, so you would use parentheses on those. Okay, another one, you've got -4 is greater than or equal to -2 times the absolute value of 3x plus 1. Here, again, you've got to isolate the absolute value first. So you're going to divide both sides by -2, which means you have to flip the sign. So you're going to have +2 is less than or equal to positive 3x plus 1, the absolute value of 3x plus 1. Because we think of this as from left to right, we should rewrite it as the absolute value of 3x plus 1 is greater than or equal to 2. And that helps us figure out what we're trying to say. So if this absolute value, the stuff in there has an absolute value greater than or equal to 2, that means it's further away from 0 than 2, which means that 3x plus 1 has to be greater than or equal to 2, or it has to be less than negative 2, less than or equal to negative 2. So 3x plus 1 would be less than or equal to negative 2. So this is a greater than problem where you've got two groups of values. And then you just solve for x. So you're going to have 3x is greater than or equal to 1, which means that x is greater than or equal to 1/3. And you've got 3x is less than or equal to negative 3, which means that x is less than or equal to negative 1. So x could be less than or equal to negative 1, or it could be greater than or equal to 1/3. So that's how you would write it. You would say all x such that x is less than or equal to negative 1, or x is greater than or equal to 1/3. And the way you would write it in interval notation is you would say from negative infinity up to negative 1, including negative 1, union the other set, x greater than or equal to 1/3. So 1/3 to infinity, including 1/3. And then you would graph it by just putting a bracket on 1/3 and an arrow going up, and then a bracket on negative 1 with an arrow going down. Okay, so here are some special cases where you really don't have to do anything as far as algebra to figure out the solution sets of these inequalities. Because if you look at this first one, you have that the absolute value of x plus 2 is less than negative 4. And you can immediately say the absolute value of x plus 2 is never going to be less than negative 4. It's never going to be negative at all. So it cannot be less than a negative number. It's got to be 0 or greater. So that's never going to happen. And so the solution set to that is just going to be the empty set. It cannot happen. So you would just write the empty set. And then for the second one here, you have that the absolute value of x plus 2 is greater than or equal to negative 4. And that is always going to be true. It's always going to be greater than negative 4, actually. And so it's always going to be greater than or equal to negative 4 because it's always going to be a positive number. So in that case, x could be anything. And you just say that x is all the real numbers, all x such that x is a real number, or you could just write negative infinity to infinity. Any x value you put into that inequality will make it true. The absolute value of x minus 5 is less than or equal to 0. When is that? Well, it can't be less than 0. An absolute value can't be less than 0, but it could equal 0. So there is one x value that could be a solution to that equation, and there's just one, and that's 5. So x equals 5 is a solution. So all x such that x is equal to 5, or you can just write 5 with a bracket around it, or you really could just write the set with 5 inside of it. Okay, then this next one, you have the absolute value of x minus 5 is greater than 0. Well, that's almost always going to be true, except for one situation. It would be equal to 0. It could be equal to 0. In that case, it wouldn't be greater. So every single number in the universe except 5 is a solution to that last one. So this is always true for every x value except when x is equal to 5. In that case, it's not greater than 0 because it's equal to 0. So this would be all x such that x is less than 5 or x is greater than 5. Or you could just say all x such that x does not equal 5. That's another way to say it. There are lots of ways to say things in set notation. And then also as the interval, you would say from negative infinity up to 5, not including 5, union 5 to infinity, not including 5. All right, so we're going to use a linear inequality in application of grades. So this says Shanice has test scores of 96, 84, 80, 98, and 88. Her score for online homework is 100, and that's weighted as 1 test grade. Shanice still needs to take the final exam, which counts as 2 test grades. What score does she need on the final to have an average of at least 90? This is a minimum average to earn an A in the class. So she's got these test grades, and we know how to find an average. So that means you just add up all the test grades and divide by the number of test grades. But there's a little bit more to it. You've got 96, 84, 80, 98, and 88. And then you've also got that 100 for her online homework. That counts as a test grade. And then in the end, you're going to have this final exam, which we don't know what that is. It's X, but you're going to have two of them because you're counting it twice. It's being counted as two test grades. So that's what we're going to take the average of, those grades right there. 1, 2, 3, 4, 5, 6, 7, 8 grades. And we want that to be 90 or better. So we're saying 546 plus 2x divided by the number of grades. We want that to be greater than or equal to 90. So if we multiply both sides by 8, we're going to have 546 plus 2x is greater than or equal to 720. And then we're going to subtract 546 on both sides, so we'll have 2x is greater than or equal to 174, and then we'll divide by 2, and that's going to give us x is greater than or equal to 87. So she has to make at least an 87 on the final in order to get an A in the class. Okay, on this last one, suppose that a machine is calibrated to dispense 8 fluid ounces of orange juice into a plastic bottle with a measurement error of no more than 0.05 fluid ounces. Let X represent the actual amount of orange juice poured into the bottle. So part A says write an absolute value inequality that represents an interval in which to estimate X. All right, X is the amount that gets poured into the bottle, right? It's supposed to be about 8 fluid ounces, but the machine is not perfect. It could be slightly more than 8. It could be slightly less than 8. X could be. So, but it's not supposed to be any more than 0.05 ounces off. What we can say is that the absolute value of X minus 8 is going to be less than or equal to 0.05. So the amount that gets poured into the bottle, which is X, it's going to be either a little more than 8 or a little less than 8, but not more than 0.05 off. That difference should be less than or equal to 0.05. The difference between the actual amount in the bottle, X, and 8, the amount it's supposed to put in there, can't be more than 0.05. It could be a little more, it could be a little less. So we use absolute value because it could be like 7.99999 ounces, or it could be 8.0001 ounces. So we want to include both possibilities, and that's why we use absolute value. And so part B says you're supposed to solve the inequality and then interpret the answer. So solve the inequality means that you're going to say X minus 8 has to be less than or equal to 0.05, and it has to be greater than or equal to negative 0.05. So and X minus 8 is greater than or equal to negative 0.05. And then if you add 8 to both sides of this one, you're going to have X is greater than or equal to 7.95. So basically, X is going to be between, the amount in the bottle is going to be between 8.05 ounces and 7.95 ounces. And then also, you want to interpret the answer. And what that means is just explain what it means. And it just means that the amount in the bottle is between 7.95 and 8.05 fluid ounces.